Once you have defined your research question, you can begin to translate that research question into a set of statements that can then be used to gather evidence and to test and make a determination between those two statements. Ultimately, this will lead you to a decision about your population. Remember, asking the questions has a predictor and an outcome. Is age related to blood pressure? Is blood pressure different for men and women? Does this new medication lower blood pressure compared to a standard medication? It all comes down to basically asking, is this variable related to that variable? Does this variable predict that variable? Is this variable different by that variable? This is your research question, and this will lead directly to your hypotheses. We have two hypotheses, the null and alternative hypotheses. If we want to know if there is a difference, then we start by assuming there is no difference. Until we understand better, right now we assume that there is no difference in, say, the mean blood pressure by gender. We assume simply that we have one mean value of blood pressure. And this is our null hypothesis. The null, by definition, null means without value, without effect, without consequence, or without significance. We'll hear the word significance a lot. It can also mean being or amounting to nothing, nil, lacking, or non-existent. Non-existent is a good way to think about this. The relationship is non-existent. The difference is non-existent. Empty, being or amounting to zero. The difference is zero. The relationship is zero. So think when you say H naught, or you talk about the null hypothesis, that we are currently assuming that there is no relationship. In statistics, that is no relationship, no correlation, no difference, or the difference is zero. Again, this is denoted H naught or HO, and that is what we currently assume, or what is the status quo. Here are some examples of our H naught. It's what we currently assume to be true, that there is no difference, there is no relationship, that X does not predict Y, that X is not related to Y, or Y is not different by X. As you can see here on the right side, our research question should be able to fill in what is the opposite of our null hypothesis for each of these statements. And that leads us directly to the alternative hypothesis. We have our H naught and our HA, and very simply, the alternative to H naught is the mutually exclusive opposite of our null hypothesis. Remember, mutually exclusive means they are separate options. So our null is no different. Our alternative would then be a difference. Let's take a look at those null hypotheses again and fill in the alternatives. So if our null is the status quo, our alternative is our research question. Our null is what we assume to be true. Our alternative is what we're looking to show. Our null is that there is no difference. Our alternative is that there is a difference. Our null is that there's no relationship. Our alternative is that there is a relationship. If X does not predict Y under our null hypothesis, X does predict Y under our alternative hypothesis. If X is not related to Y under our null hypothesis, then X is related to Y under our alternative hypothesis. And finally, if Y is not different by X under our null hypothesis, then Y is different by X under our alternative hypothesis. Evidence is our data. So in order to choose between the null and alternative, we need that evidence. We need to collect data and apply it to this question. We begin with our initial summary of the data. This is something that you always do. You do a univariate distribution on your variables that you will be working with to answer this question. Remember, in JUMP, that's analyze and distribution on single variables. Check for errors and outliers or weird observations. This is critically important. Do not delete any rows of data unless you verify if that is an unfixable error. A good example of that is a systolic blood pressure of 625. That is not a real value. That is obviously an error. If you cannot confirm or fix that error, then you can delete that observation because that's not a real value. If, however, you see a systolic blood pressure of 195, and even though that's very extreme, that's still a possible value. Verify that any of your outlier or extreme values are not simply errors. If they're errors, fix them. If they're not errors, but they are possible values, leave them in. Then continue on to summarize each variable that you'll be working with using the applicable statistics. So an n and a percent for your categorical data, a mean and standard deviation or median interquartile range or median range for your continuous variables. Once you've summarized each of your variables univariately, we're going to move on to the bivariate summary. Remember, we're now dealing with two variables, and that does lead us to a bivariate summary. So we need to summarize the outcome by the predictor. We need to bring evidence to bear to answer that question. Since we know that our outcome is our y variable and our predictor is our x variable, the generic way to say this would be fit y by x. So we are going to use JUMP, and we're going to use the JUMP platform called fit y by x. This is also under the Analyze menu. There are three options we will look at: a contingency table, that's when we have a categorical x and a categorical y. We'll be looking at proportions. We'll also look at group means, where we have a categorical x and a continuous y. And we'll be looking at correlation. This is when you have a continuous x and a continuous y. We'll be looking to see as x increases, what happens to y? Does y increase or decrease? First, let's look at contingency tables. This is for two categorical variables. You'll hear it called contingency table, a 2 by 2 table, which could also be a R by C or rows by columns table. It's also called a frequency table. You will be reporting n's and percents when you are dealing with two categorical variables in your fit y by x. Let's take a quick look at the JUMP output. This is the output that you'll see for every fit y by x. In this example from the zip bike data, we're looking at helmet use as our y and the sex of the rider as our x. The first thing you get in JUMP is this image called the mosaic plot. This plot is only for you. This plot is not for publication. This is just a graphical representation for you to quickly scan and see, are our blue or top portions similar by each of our x levels, and are they similar to the far right bar? The far right bar shows the overall percentage of your outcome, so what percentage of people are wearing a helmet and what are not. And then you can see it by gender, by female and by male. If the proportions are similar by your X category, then you'll see the same or consistent or very similar proportions of the blue and the red or the top and the bottom across all levels. Again, I cannot stress enough, this plot is not for publication. There are better ways to graphically display percentages, but this is simply what you'll see in the JUMP output first. You can see in a contingency table that your X variable becomes the rows. Here we have female and male. And your Y variable, your outcome, is the columns. Helmet use, no or yes. You always want to give the overall percentage of your outcome. So 43.3% or 13 out of 30 wear a helmet. That's your overall percentage of your outcome of interest. And then also give it by your X variable. In this case, 46.7% of females wear a helmet and 40.0% of males wear a helmet. These are also called conditional proportions, so we are conditioning on the sex of the rider. Given the rider is a female or conditioned on female, we can report that 46.7% of them wear a helmet. Conditioned on males or given male riders, 40% of males wear a helmet. In general, if you've set up your X to be your rows and your Y to be your columns, you want to use row percentages. This is the bottom percentage given in JUMP. So now we can move on from there to a continuous Y with a categorical X. In this case, you'll report the overall mean and standard deviation, or again, median IQR, median range, but you'll also report those values for each group in X. So let's look at the JUMP output. When you initially fit Y by X for a continuous outcome and a categorical X, you will get a graph that looks like this. This is not your analysis. In this case, unlike a contingency table, you have to tell JUMP what you want. It's very basic. Again, this graph is not for publication. This is a starting off point. It's important to note here that your outcome, your Y variable, is on the Y axis. Your X variable, your groups, are shown on the X axis. And there is a point observed for each response level. This example differentiates slightly from the example in your notes, which shows an outcome of zip times by sex, but this is just another example, and you can see how the outputs look very similar. So how do you get the analysis for this? You have to ask JUMP under the one-way analysis of age by sex for the means and standard deviations, and then also for the quantiles. We've seen quantiles and the means and standard deviations before in the univariate analysis. This simply shows them by the levels of your X variable. In the plot, the boxes go with the quantiles. Those are called box plots. And very small and subtle are some dashes, and those go with the means and standard deviations. Again, the gray bar is the overall mean age, and you can see for the females that there are a much wider distribution of responses. In fact, females go from 19 to 74, and you can see for the males that they go from 19 to 63. You could see here that the mean for females is 38.8 years of age with a standard deviation of 14.5, and for males they are slightly younger at 31 years mean age with a standard deviation of 11.5. You report the outcome similarly as you would just for the outcome univariately, only you now report it by group. So means and standard deviations, or the 5-number summary with a minimum, 25th percentile, median, 75th percentile, or maximum. So now what about two continuous variables? Again, fit Y by X. You'll see a pattern here for bivariate analyses. Fit Y by X. You'll report the summary for each of the variables. So independently, you'll do a univariate distribution for each of your continuous variables, and then you will report the direction and strength of the relationship between the two variables. Let's jump into the JUMP output. Again, you get a very basic, not for publication as is figure. You have your outcome on your y-axis, your x or predictor on your x-axis. These points are pairs of observed outcomes. And again, this is not the analysis. Using the red drop down in JUMP, you need to ask JUMP to give you the correlation. So you do that by asking for a density ellipse and asking for the 0.95 or 0.95 or 95% density ellipse. And then you'll use the gray triangle to open the results under bivariate normal ellipse. In this case, you just want to pay attention right now to the information on the left side of the table. You need to report the correlation value. So what is the actual value of correlation to 2 decimal places? Is it positive or negative? Meaning, is it a positive relationship? So as x increases, y increases. Or is it an inverse or negative relationship? So as x increases, does y decrease? Ignore the significant probability for now. We will get to that later in this course. But for this particular relationship, we would say that there is a moderate negative relationship between the age of the rider and zip times. That is, as age increases, the number of times that people have ridden a zip bike declines or decreases. You would also then report the mean age with standard deviation and the mean number of zip times with that standard deviation. This is how we translate from a research question to a hypothesis set, so a null and alternative hypotheses. This is how we evaluate the evidence and utilize the bivariate summary or fit y by x to address those questions. For the second part of the activity, again using the SBP weight data set, for each of the questions that you came up with in the first part, use fit y by x to fill out the blanks on the worksheet. They are highlighted and underlined. So assess those relationships, categorical and categorical, continuous and categorical, and to continuous, and complete the worksheet.